here we have some copper sulfate solution and an iron nail. Here we have some iron sulfate solution and a piece of copper, and we're going to try and figure out which one is the most reactive. I just have a little bit of wire there so I can stick it into my test tube and still get it out again. So I put some copper sulfate in. And I don't need to cover the whole nail so that we can see if there's a difference at the top. And then on the other side I'll add some iron sulfate. Add some iron sulfate to that one. And we can see that we started with a blue copper sulfate solution. And if we wait a little while, we'll begin to see a little bit of reaction. Okay, so it's been a couple of minutes, so you'll see this is a darker blue and this is a lighter blue, so the amount of blue's gone. And if we were to pull that nail out of there, we can see a really stark difference at the bottom. So it's a brown colour, so there's some coppers going on there, and we can see at the top it hasn't. And if we feel it, we'll feel it's a little bit rough and it's a little bit thinner. It's best to leave this overnight to see a contrast. And then if we were to compare that to the copper and iron sulfate solution, we see that there's no reaction. So that would say that the iron nail is more reactive than the copper, which is what our activity series suggests. So here's the original copper sulfate solution as a control. It's still blue, and then when we come over to look at this, we can see that the colour of the solution has changed, and we can see that there are now there's a discoloration between the iron nail at the top and the nail at the bottom, so we can see that the colour of the solution has changed, and that copper has now gone onto the nail. If we come over and look at copper and iron sulfate, we can see no reaction has occurred. That shows that the iron is more reactive than the copper, and so you can see as I bring that up, some of those ions come off, and if we can see that there is significant corrosion, that the iron nail has actually got thinner, that it's a lot more bumpy, and that some of those copper ions on the outside, or copper metal on the outside, just fall off. Now if we get some sodium hydroxide and put it into a test tube, and then using a clean dropper, we collect some of that solution that used to be copper sulfate, and then we put it into that sodium hydroxide solution. We're seeing a precipitate forming, which is a light greeny colour. And then if we were to compare that to these two, it is the Fe2+, because it's clearly not the brown colour, so we've made it Fe2+ ions. If we put sodium hydroxide in another test tube, and then this time using another clean dropper, if we got some of the copper sulfate that we used the first time, and then put it in, you can see that precipitate is quite different. Cool, yep.
This is the Fe3+ one, and you get your rust brown gelatinous precipitate. That's your Fe3+, that's what they associate with rust and so on. And then you add a couple of drops of this into here, and you get a blackish. Haha, that's interesting.
I don't know if it worked.
Yeah, it's